Excellencies, distinguished guests, ladies and gentlemen, good morning. I hope everyone who's been with us thus far have had a well-deserved rest. And for our new joiners, welcome. We are pleased and honored to have you all here, participating and attending this globally important event. My name is Sarah Al-Amri, and I will be the Master of Ceremony today. Welcome to the third and final day of the 6th International Rain Enhancement Forum. I hope you all have found the past 2 days to be informative, engaging, and thought-provoking. Like the last 2 days, we have brought together an incredible lineup of speakers and panelists who will share their knowledge and expertise on a wide range of topics related to the rain enhancement field. Today, our first session is under the title, Capacity Building Within the UAE Research Program for Rain Enhancement Science. We will start the session with a discussion panel featuring key panelists including Dr. Prashanth Marpu, Vice President for Research and Development and Bayanat AI, Dr. Steve Griffiths, Senior Vice President for Research and Development at Khalifa University in UAE, Mr. Ricardo Taksiri, a Program Officer of the Governance Support Office and International Renewable Energy Agency, Mr. Mohammed Al-Wahdi, a Chairperson in Youth SDGs Council and a Seismic Engineer in the National Center of Meteorology, Alex Hurst, a PhD candidate from the University of Colorado Boulder, USA, and the session moderator, Dr. Dion Terblanche, Chief Scientist from Science Prime. And again, I would like to invite our audience to take part in our discussion by sharing their questions via our online platform. To do so, please scan the QR code placed on your table. I will make sure to have your questions addressed to our panelists. Dr. Dion, the floor is yours.
So good morning, ladies and gentlemen. We've eventually reached the last day of this very important meeting, and we've had some very good discussions from our presenters in the panel discussions, and also, of course, the very important discussions that happen over lunch, dinner, and during coffee breaks. And so this is a very important panel regarding capacity building or capacity development, because in a complex field like we're dealing with here, it's always important to make sure that there's continuity and that the young generation can actually take on the challenges and get inspired to address some of the really critical issues that we face as humankind. So I would like to ask the panel members a few questions, and you are also welcome to send in any further questions that you might have. So, Dr. Prashanth, based on your experience with higher education in the UAE, how can we better prepare the UAE youth in STEM to tackle climate-related challenges of the next decade and more? And how does your corporation, Bayanat, incorporate youth and capacity development in their business model?
Thank you. So going with the first question, basically, I'm a firm believer of project-based learning. So that's the only way we can probably embed them directly, youth directly into these type of advanced programs and so on. So, I mean, I had a couple of observations recently. It's like the entire field of, climate modeling or climate-related things basically is changing so quickly with all these climate change events. Yesterday there was rain, and then there was a cricket match that was cancelled, and that's probably a first that happened in Dubai. Having something like that happening in Dubai is crazy. Now, people are aware of these things. They're observing how things are changing and so on. So, if we can capture these changes and tell people that, look, you need to start thinking about this thing and how they can contribute to supporting mitigation programs or any of those programs which help in stopping some of these effects, basically, it would be amazing. So the way for me is to start them early in some education programs where there is project-based learning, where things like all the sciences can help in real-world applications where they can really show the value of those learnings, basically. So that would be one thing. At Bayanat, it's been a year. So we are a geospatial company, largely focused now on analytics development, a lot of AI work going on and so on. So it's been a year. We started a small group on weather modeling and climate-related things. So this year, our plan is to work closely with universities like Khalifa University and other universities here to engage in small research programs. And there is also a plan for us to start a resident postdoctoral program. So these are some of the initial steps. At the same time, we are taking these climate aspects and embedding them into our applications. For example, one of the key applications we look into is satellite imaging. Satellite imaging is affected by a number of weather-related things, clouds, dust in this region, and so on. Even for us to make a decision when to acquire an image and not acquire an image, it's important for us to learn all these things. So these are some of these things which come in and help us in our own regular applications, which also means that we need to inculcate that small department which can support this continuously, which would be a place for us to start engaging more with entities like NCM, universities, and start growing that department into a bigger one.
Thank you very much. I think project-based learning is really important, and of course this program is an ideal platform for that type of thing, because you deal with practical things very close to the real weather out there, but you also deal with highly complex theoretical and technical issues. So thank you for that answer. Alex, you represent one of the group of the new generation that is getting involved in this field. So I would like to ask you, as a PhD student at the University of Colorado, where you've been working with Professor Eric Frew on his UAE project, focusing on UASs for cloud measurement and targeting. What attracted you to this project, and what are some of the challenges and or lessons you learned from the work? And do you have any further plans stemming from your research outcomes?
Yeah, thank you so much for the question. It's an honor to be here, honor to be on this panel. So my work as a PhD student has largely focused on autonomous robotic control for a variety of information gathering tasks. And I've had a great opportunity to work on the UAE REP project with Dr. Frew to apply some of these technologies to cloud seeing and rain enhancement problems. I think what drew me to this project was just, it's such a unique application of autonomous aerial robotic technology with so many challenges ranging from like tasking to autonomous decision making to human-robot interaction. There's really so much to explore in this domain that's really exciting for me. It also provided me a great opportunity to collaborate with people from across the world. We had collaborators in South Africa, all across the US, and that was a very exciting opportunity for me. In terms of like some of the challenges that we faced, I think small, especially fixed wing, autonomous uncrewed aircraft systems have a lot of potential to provide a lot of utility to our society generally. But there are a lot of challenges that that we face when applying these things to atmospheric science problems. Of course, they're inherently like size, weight, and power limited, so hardware issues are a big concern. But also developing autonomy algorithms that are useful and informative and interpretable is a big outstanding challenge. But possibly like one of the biggest lessons I learned from this project was how important field experiments are, and actually going out and deploying these systems in the real world, seeing how they work. And I think that's where you gain so much knowledge about what the real challenges are and where further research needs to be directed. I think that answered. Was that all your questions? Or?
No,
yeah.
that's it. I think you covered it well, and I think this point that you made about going out in the field and doing field experiments, this is the opportunity that this program also presents, and it's really an important facet of doing science is actually not just to look at the theory, but actually to translate that theory into practice, and that's why that aspect is also an emphasis of the fifth cycle of projects that we are embarking on. Dr. Steve, as a member of the Scientific Direction Committee, I know very well that you've always had a keen eye on looking at how projects deal with the issue of capacity development, and it's also one of the elements that all the projects need to include. Can you speak to us on the impact of capacity building opportunities offered by these UAE REP projects, and how important is collaboration between industry and universities, higher education for these type of research grants, and I might even add also the private sector?
Sure. Thank you for the question. It's a pleasure to be here today and participating in the IREF. I've had the privilege of being involved with the program since its inception. And when the program was put together, as we thought about what components would go into a solicitation for the research that would come into the UE and help evolve the sector, one of the areas that was very important was capacity building. And so today, when you submit a proposal to the program for a new award, about 15% of the overall merit assessment is based on capacity building. When we look at capacity building, there are primarily three areas we'd like to see things taking place. One is on the human capital side, so a lot of getting students involved, making sure researchers involved, trying to build up that capability through the people that are involved in the project. Secondly, there's infrastructure. So infrastructure and also technology capability development is the second piece we look at, how we can bring that into the context of each of the programs that are put forward by the proposers. And the third is engagement. Today is an example of engagement. There's other forms I'll talk about shortly. So throughout the course of the program, since the first awards and now going into this new cycle, on the human capital development side, the manpower development side, we've had about 200 researchers involved in the program and at various levels. What's been very nice is about 50 of those researchers, they've been students. And when you look at how that then translates into the UE context, probably a quarter of those students have been from the UE. So we start to see that move from the pure researcher toward the future workforce, the future scientist, and then how that translates locally. On the infrastructure side, there's been some very impressive work done. I'm involved in many, many research programs in the UE and internationally. And what I thought was very nice about this program is that there's a collaboration between the NCM and the project participants to develop technologies, develop infrastructure that then gets localized into the context of the UE environment. And so when we look at what's been accomplished to date, we see a number of activities and areas I'll broadly outline as being the data collection, many times getting the right data to be analyzed and utilized increasingly for artificial intelligence, machine learning, but for other purposes to inform numerical weather models. That's hard, and there's been a lot of progress in bringing very sophisticated instrumentation into the country, collecting good data, and now being able to leverage those data for our understanding of weather and rainfall enhancement opportunities. The second piece is model development. So I'm a big believer in modeling that's physics-based, increasingly machine learning-based, and to further the understanding of weather and precipitation opportunities within the country. You need to be able to have robust physics-based models and then complement those with machine learning. Majority of the projects that we've awarded, again, have had work in developing components of modeling. Many of these components now factor into what we're doing with the Weather Research and Forecasting model, which is a large open source platform for developing understanding of weather patterns, and particularly bringing in the context of how we can understand cloud chemistry, cloud physics, to enhance our understanding of the opportunities to enhance and stimulate rainfall. So I think the modeling piece has been extraordinarily successful as well, competency data. And the third is the technology development itself. So you've heard throughout the conference, there's been a lot of work on cloud seeding materials, new novel materials. One in particular has progressed from fundamental science around coating salt with titanium dioxide, taking it through relevant environment demonstrations in cloud chambers, and now showing how that works in an operational capacity in new awarded projects in the UE. It's extraordinarily successful to see fundamental science move through the entire technology readiness spectrum and end up being a technology produced in country to create value in country. So I think on the material side, there's been great progress. On the hardware technology side, likewise, there's been some very interesting work on drones. So Professor Frew and his students have done a great number of studies, and they've demonstrated in the relevant environment of the United States, we're looking to have that done here, how the drones that do the cloud measurements and then ultimately over time could deliver cloud-seeing materials can be deployed. It's been very nice. We've also seen drones look at charge sensing in clouds and delivery of charge. It's also been something that's been demonstrated. So on the robotics side, I think there's a robotics and drones, good work that's been done. And then we've had, very interestingly enough, work to stimulate and show how new clouds can be created, which I thought was kind of the most interesting work, turning jet engine upside down and trying to create, under the right environmental condition, the cloud condensation nuclei in an environment to create rainfall in clouds. Hasn't fully worked out the way we wanted it 100%, but it's been a great effort to bring infrastructure into the country and get that deployed and show how that can add value. So those are several examples of how we brought in the infrastructure on the technology side to complement the data and the modeling. And the engagement, last thing I'll say on that, and I'll go into the question about the industry and academia. On the engagement side, IREF, of course, annually held, is a great opportunity for all the investigators to get together and show what they're doing and really have a best-in-class, I think, approach to showing the world what a program in advanced research can do when you take not just the view of doing science, but trying to translate science to impact. And throughout the year, the NCM and the UAREP, they continue to have these online opportunities for the investigators and then the community to engage in dialogue. And so we want to see that happening. We want to see more of the work that's been done coming into the context of the UE and having those discussions. When it comes to the value of the industry or the not necessarily always industry, sometimes it's more of an applied R&D institute working with academia. The way I see the value, broadly speaking, of an innovation ecosystem is you got human capital is one component to it. You've got the development of novel technologies, and innovation is a sort of the other side of the spectrum, and then the knowledge creation, scientific discovery in the middle. The industry and the more advanced research institutes are really good at innovation. They push things that are fairly well progressed through science into practical value, which in its own right is very good. But to get the true value of the scientific discovery, the novel thinking that sometimes students and faculty can bring to bear, and also to engage students, which are part of the future workforce and the future scientists, that engagement between the industry and the academia to say we're going to get students involved in the work that we're doing on innovation, looking for new innovations to overcome those challenging problems that don't have a direct solution, and then the industry helping to translate those new understandings into value creation, innovation. That kind of dynamic is something you cannot go either from the purely academic perspective or the purely industrial perspective. So answering both your questions in a long answer, I'd say the program has been, at least from my view, one of the most successful I've been involved in at achieving human capital and capacity development, and looking forward to seeing the next cycle provide further opportunities for that.
Thank you, Steve. There's a related question from the audience that I want a short answer from you is, given the importance of high-resolution modeling to rainfall enhancement research, what are the strategies or plans to expand computing and modeling facilities in the UAE?
Well, I can say one thing. I don't know if people are broadly aware of it, but the NCM itself has a fairly new Cray supercomputer, which is a wonderful environment in order to take your numerical weather modeling, if it's physics-based, into whole new directions with the computational power that affords, and also to deploy some of the things I talked about from the R&D that's been done in a different environment, your relevant environment, to demonstrate that all these model components work in, over time, a translation to the production environment where the weather forecasting is actually happening. So the NCM itself, National Center for Meteorology, is greatly on top of the need for computing capacity. Bayonet had the opportunity to work with, actually visit them the other day, and they had many neat technologies, but they're, in the UAE, they're one of the organizations which embodies the country's full commitment to bringing computational capability to all the areas that I think are going to be, certainly they already are, the fourth industrial revolution, and then we talk about the fifth in cyber physical systems. All those computational capabilities required are already now, I'd say, being led in the country. So the likes of NCM, G42, Bayonet, you can't go anywhere and not see the country have best-in-class computing capabilities. And at the university, we ourselves, not quite as sophisticated as what you see from NCM and BINAP, but we've invested heavily in our own high-performance computing environment so that we can support our researchers to be able to do the types of work that translates to value for the rainfall enhancement program.
Thank you, Steve. Mohammed, you are the chairperson of the UAE's National Youth Council on Sustainable Development Goals. Can you shed some light on your council's mission, objectives, and achievements or milestones reached to date? And how can we better prepare next generations for more stringent adoption of the SDGs? Because these things are supposed to be very practical goals that we need to meet as nations around the world.
Yes, thanks for the question, and it's a pleasure for me to be here today at the IREF. Please allow me to start with a little background about the SDGs for those who haven't come across the term yet. So in 2000, the United Nations announced the Millennium Development Goals, which are 8 goals to be achieved by 2015. Those goals were actually tackling hot topics at that time, including hunger, poverty, healthcare, diseases. And closer to that date, and at the high-level political forum in 2015, the United Nations announced a more comprehensive plan to take over the Millennium Development Goals, which is called the Sustainable Development Goals, commonly known as SDGs. So SDGs are 17 goals adopted by the United Nations, which are covering a wider angle of fields and targets, including healthcare, including education, inequality, wildlife, marine life, climate action, peace and justice, water security, food security, which is actually a topic of this forum. The SDGs file is a vital file for the UAE for a simple fact that the UAE was part of the negotiations and part of the committee that developed those SDGs. And the UAE was actually the representative of Asia along with Singapore and Cyprus in the negotiations which took place between 2012-2015. So the UAE formed the SDGs National Committee, which actually directly followed the Prime Minister office, to govern the government policies and the government direction into the achieving the SDGs. And part of the bodies that follows the National Committee is the SDGs Youth Council, the National SDGs Youth Council, which I'm part of. So our aim at the Council is to harness and to apply youth energy and youth potential to achieve those goals and to build a sustainable future to even what is beyond 2030. Today in the UAE we have 2071 vision. So how can we maintain what we achieved till now, and how can we build on that? So currently we developed our strategic plan, which is made of 8 strategic initiatives along with many side events and participations. We actually try to apply different approaches in achieving those goals through arts, through education, through economy, through research, through media. And how can we get the students more involved or the youth more involved? I think the most important thing is building capabilities. Here we need national researchers, national experts in the hot topic, the hot scientific topics. His Highness Sheikh Mohammed bin Zayed once said, the intellectual knows something about everything, but the expert knows everything about something. And that's the quality that we need. That's the quality that we seek to drive the change in the coming future. And then after that, we need to mainstream the SDGs. We had enough of raising awareness. Everyone today knows about the climate change, heard about the climate change, but we need to mainstream those SDGs, those goals into our life, into the youth life, into what they are doing and what they are caring of, into their work, into their businesses. How can we get those SDGs involved into the startups? How can we shift the current startup mindset from F&B sector to the SDGs, which is something the government currently is investing on. And I think everyone agrees that investing with the government is a win-win rather than dealing with the public or the society alone. So, yeah, I hope that answers your questions.
Oh, thank you very much. I think it's really important from a very early age to expose young people, primary school or whatever, and have the curriculum including those issues that are challenges to humankind. And so it's a long-term process, and it involves many sectors of government to make sure that we've got a new generation that is capable, interested, and driven to address some of these rather interesting questions. So, Ricardo, you are involved with IRENA, a leading global international agency with the drive to support the widespread adoption and sustainable use of all forms of renewable energy. What are some of the outreach activities that IRENA conducts internationally, but specifically also regarding the UAE's youth on climate and sustainability related topics? And is water production from operational cloud seeding activities incorporated in your reporting on the UAE's energy transformation?
Thank you very much for inviting me today. Absolutely. As IRENA, we do have several initiatives that are specifically targeting young people. We are the only intergovernmental organization that is based not only in the UAE with its headquarters, but also in the region. And this gives us a lot of advantages in order to work with also young people that are based in the UAE and in the region itself. As IRENA, we have launched since 2015 targeted initiatives on creating capacity and building capacity for young people and students. We started with the Grow at IRENA initiative, which meant to offer a summer traineeship to UAE-based students, mainly university students, of course, in order to support their starting of their career and also to have a concrete experience on the job within an intergovernmental organization. When we talk about youth engagement and capacity building for young people, we as IRENA have been partnering with several entities, also nationally. Recently, we also partnered with the Youth Arab Center to the launch of the skill report for the green sector. This happened only a few days ago during the Abu Dhabi Sustainability Week. And in addition to that, we also launched the IRENA Youth Forum, which is an annual gathering which brings young people not only from the region and UAE, but also from our member countries, which are 168. The combination of the two groups of young people has been always a success because for us it is important to support the development, the sustainable development of the UAE by also connecting young people from high schools, from universities, with other young people and students that are coming from around the world. During the last forum, we have more than 140 young people, and they were both from the UAE and also from other regions. And we were able to see how important it is to let them work together to organize workshops, capacity building workshops related to, of course, the main areas of work of IRENA, in order to ensure that there is also let's say a kind of knowledge transfer between students from different regions and background. We have also established and launched other initiatives that are targeting specifically UAE-based students. One is the IRENA Student Training Program to support governing body meetings, which is a very long title, but basically the main purpose is to have a team of young people from high schools working with us, with the IRENA Secretariat, in the designing and preparation and also delivery of our governing body meetings. Governing body meetings are the meetings of our governing bodies, so the Assembly, which is the main one, and also the Council meetings. In order to do that, we want to expose young people, high school students, to the work of an international organization, but at the same time we want them also to capture all the knowledge that has been is shared, is discussed during the meetings that are held by our organization. We have also launched during the pandemic some online virtual capacity building programs, such as the Student Leaders Program. The very first edition meant to target only UAE-based students, but then considering the high demand, we open it also to international students, and now we are going to run the fifth edition of this program. So a lot of initiatives, a lot of engagement with also national partners and organizations, including also with the Ministry of Education of the UAE, with which we signed a partnership agreement in 2019 in order to work together for the creation and development of a curricula on renewable energy in order to be implemented nationally and adopted nationally, but also to be used as a basis by our membership in their path to a sustainable development at national level.
Thank you very much, Ricardo. So we've got a few questions from the audience that are directly related to the computing capacities that NCM has now and some of the possible research funding opportunities provided. But in the matter of interest of time, I would encourage those that want to know that type of detailed information to maybe engage directly with the NCM staff that's around. Omar is the head of research. He's around as well, and some of the other members of MCM. I'm sure that they will give you detailed information for that. Because the next session is a poster session where some of these early career scientists, some slightly younger than others, will also present their work, and it's important that we set aside time to engage with them and acknowledge also their important contribution to this meeting. So a takeaway message for me from this discussion is actually that the forum and this program should also put action where it says things are important, and maybe at the next forum we should set aside a specific session that can be organized by the early career scientists, and so that we can hear from them without boundaries what do they believe is important. I was involved in the creation of a community called the Young Earth System Scientists, a large group of young scientists around the world that are supported by the World Climate Research Program and other international programs. And this group has gained so much momentum that they have actually now, without funding from these big international programs, arranging their own conferences and things like that. And so I think it's really important that we also show how important we gauge this issue by, in the next forum, having a specific session organized by young people without us prescribing them how to go about it. And I think we will be surprised what comes out of that, and we might learn from them. So to the panel members, thank you very much for your contribution to this very important topic, because the next generation is really important to take up the challenges and move us along. They are better equipped than us, old generation, because they are more accustomed to the new technologies and the potential that that holds. Thank you so much.
Thank you.
Thank you, our panelists, for sharing your valuable insights on the topic. I would like now to invite you to tour around for looking at our poster session. We have the pleasure of showcasing 6 posters from some of the brightest minds in the field, including Dr. Agnav Sen Gupta, a research scientist from Center for for Western Weather and Water Extremes, Scripps Institute of Oceanography, USA. Alex Hurst, a PhD candidate in University of Colorado Boulder, USA. Ahmed Al-Kamali, a cloud seeding executor in the UAE National Center of Meteorology and a PhD candidate in the University of Reading in the UK. Heno Havinga, a senior lecturer in Northwest University in South Africa. Kanshubi Malkrov, a research engineer in the Hail Suppression Research Center in Russia. And Noor Shamsi, numerical forecasting specialist in the UAE National Center of Meteorology.
see, I'll probably have to turn and look over there. And this we're going to leave on.
Yeah, we will leave it and we will ask them.
Sort of the whole discussion time until we debrief. Okay. I can figure that out now. It's the arrow that's the yes, right? Okay. I wonder if I could put my own little
Thank you.
Welcome back, ladies and gentlemen. We hope you enjoyed the poster session. And now, we are moving on to our town hall meeting titled Outlook on Current Research Gaps and Targeted Solutions in Rain Enhancement Research. To begin our town hall meeting, I invite Dr. Richard Binky, President of Science Prime in the USA, to give us an introduction to the meeting and explain its structure.
Okay, well, I'm glad you're back because you might find it confusing if you come in late. You might even find it confusing if you came in on time. So I'm going to go over exactly what we're going to try to do in this session. I think this is going to be one of the most interesting sessions in the meeting. It has the potential to be. It all depends on you folks. I mean, we know we've had, let me just move this forward if it works. There we go. So this is an open format session. We tried this a couple years ago and it worked pretty well. And we know we have a bunch of experts here from all different fields and different countries. So we have this international cooperation almost built into what we're going to be doing here. And in all these different fields. So that's the first bullet. And many of you have had prior experience in this program doing different things, and if you haven't, you're probably well aware of other initiatives. So this UAE REP is not kind of a mystery thing. Plus, we've had very nice talks for the last 2 days, pointing out how important this program is and the different facets that the program has. So we know we have these various different facets to the program, and we actually feel that there's 5 priority areas. Well, there's 2 really very big priority areas. That's cloud formation and rain enhancement. But below that, we have 5 other priority areas that I'll get to in a second. And each one of these has gaps and challenges, and we'd like to further define what those gaps and challenges are to help us inform us on the next solicitation, as well as when we review the incoming proposals, what are the things that we might want to highlight. So we'll be doing that. So when it says current and future research needs, it's exactly what we mean. Current research needs, ones that we really are going to be thinking we can perhaps do even in the next set of proposals, and future, looking beyond that into a broader, longer timeline. So the 5 priority areas will be meeting in parallel. So the tables you might notice, there's 5 tables that have assignments to them, and I'll get to your assignment, or you might see your assignment soon, but each one of these, innovation in rain enhancement, advances in physics-based and AI-driven modeling and forecasting, field and airborne campaigns, observation platforms, on-main system, evaluation of rain enhancement efficiency and technology readiness level considerations. Now this last one we haven't heard much about, but it's important, and we're trying to insert it into a very high priority place in the incoming set of proposals. Anyway, here's how it's going to work. When I get done here, which hopefully will be pretty soon, each working group has been assigned a leader. The leaders, so I hope you know who you are, because you will be coming up on this stage and giving a short 5 to 10 minute presentation. So there's 5 of those. When that's done, approximately 12:45, we'll then meet at our tables, and you'll see next slide shows which tables and who's at them. That's the minimum people we want. Anybody can go anywhere, actually, and if you're not on this list, just feel free to find a chair and sit in on whatever one you want to listen to and participate in. Participation is the key to this if it's going to work. So from 12:05 to 12:45, we have this discussion, and from 12:05 to 12:45, we have each one of the working group leaders come up here and give their 5 to 10 minute presentation. After that, the working groups will meet for 45 minutes at their designated tables. And then after that 45 minutes, we're actually going to take a lunch break. Probably the working group leaders won't take that much of a lunch break because when we come back, we'll be expecting them to summarize and discuss what their group found in each one of these areas. After those quick presentations, we'll open up the whole thing to the floor, and anybody can ask any questions to anyone. And that'll be about it. At 3:50, we'll be finished with the hardest part, the working part of this, and we'll go into a wrap-up mode. But actually, I've been told that there'll be a photo. So if you don't like the working group and you were going to leave early, don't do it because there's a photo at right after the working groups are over. In the group photo, you want to be in that, and then you'll hear the final talks. So that's kind of how it's going to work. So at the very beginning, I'd like to ask the group leader. Oh, wait, very important. Sorry. These are the group leaders, and these are the people that we're going to leave this. Whoops. We're going to leave this on throughout the entire time. So that's where you might want to go. Hopefully, if you're on that list, you will go to that table. If you're not on that list, go to wherever you want. And even if you are on that list, after a while, feel free you can go to another table too. But we do expect some in-depth discussions and some concrete, specific recommendations at the end. Please don't give us really some vague recommendation. Be as specific as you can. And so there it is, 12:05 to 12:45, the 5-minute things, and then later the closing things after the 45 minutes of discussion. So the very first one, I'd like to ask Duncan to come up here and talk about innovation in rain enhancement and cloud formation systems and technologies. Duncan?
Okay, so the topic assigned here is innovation in rain enhancement and cloud formation systems and technologies. So there's rain enhancement, cloud formation, and technologies related to that. So what is needed for innovation and rain enhancement technology? One of the things that we've talked about quite a bit over the last few days is the importance of targeting, that is delivery of the right amount of seeding material, also the right seeding agent, and placing it at the right time and the right place. So what type of technology would be suitable to assist with making innovations particular to that objective? Another one is to inform precise targeting. So with reference to airborne seeding, the pilot is limited by not having a complete picture when they approach the storm system. So what can we do in terms of technology to assist with providing up-to-date information that's not old, so that they can make more informed decisions. Operational data products can help in this respect, especially those that are of high technology readiness level and available in real time. This increases the targeting lead time, so getting the seeding material at the appropriate time, but also prior to the time when that seeding needs to occur is a preference. Documentation of the cloud microphysical process. One thing we've talked about is the importance of studying the cloud processes that are pre-existing prior to us modifying them. So what is the technology there that could be brought in, especially that technology that is ready to be implemented in operations, and then developing tools through research programs and making those available for operational use. So what are some of the technology requirements for effective seeding? In which clouds is glaciogenic seeding beneficial? Measuring the optimal pre-existing condition for those cases. In which clouds is hygroscopic seeding beneficial? Again, measuring the optimal pre-existing conditions for those cases, but also continue to work on optimizing the size and concentration of hygroscopic particles that are used for hygroscopic seeding. Technology related to that is important. How to identify a seedable cloud, how to conduct effective seeding, and how to identify a seeding effect. Those aspects are related to targeting, but also related to measuring, identifying first a seeding effect, which then is important in refining our hypothesis and adapting our seeding strategies. And you may think about this in this space. This is very conceptual, but we traditionally perform hygroscopic and glaciogenic seeding based on cloud base height and based on the temperature at which the agents are effective, but there's also another dimension which is related to the aerosol loading. So how do we obtain that information and present that information in a way that we can more accurately identify the window of opportunity for seeding? And previous work that has been done around the world with establishing these pre-existing conditions is quite detailed and not presented in a manner that is actionable. So what you see here is quite complicated for operational use. We have on the left side here aerosol size distributions. To obtain that aerosol size distributions, there's 3 instruments there and quite a bit of processing involved with obtaining a average size distribution at cloud base, which needs to be considered for seeding decisions. So how do we simplify that part? And then on the right there, you see the figure of effective diameter or effective radius with cloud base height. Again, this is information that is needed for seeding decisions, but how do we simplify that information in order to make seeding decisions? In terms of cloud formation and instrumentation or technology that is available to simulate the cloud formation processes that could be deployed on the ground to help with operational rainfall enhancement. Again, there's challenges here just because of the different processes that are related to aerosols forming cloud condensation nuclei and then aerosols forming ice particles. There are many different pathways for this to occur. So the technology that is immediately available is not, these are complex instruments to operate. But there are some examples where this technology has become useful for seeding operations. For example, what you see on the right there, these are CCN aerosol and CCN concentrations from Saudi Arabia in August 2009, where we see the impact of the sea breeze on the aerosol number concentration for a particular day and how that impacts the CCN concentration. So not having any knowledge of how these aerosols are potentially interacting with cloud targets could be detrimental for the seeding. If we seed the cloud with the wrong seeding agent or seed the cloud inappropriately, we may not get the desired effect that we were planning to get from our hypothesis. So this is where these tools become useful. So to conclude here, we are encouraged to focus on technology that can translate into the operational programs and moving technology from research to operations. This involves discrete steps. We need to recognize that an innovation has operational value. Sometimes we don't do that. We continue to operate in the research space, and we don't connect with the operational folks to see what their requirements are to translate that research to for it to have the desired operational value. We need to communicate the potential for that research, acquire resources, which could be challenging because you're trying to realize the potential of this technology, but the resources to develop that technology may be limited, and use that resources to reduce the risk of developing that technology, and then once the technology is developed, translate that technology into operations. So that's my talk there. Those that are in my team, keep this in mind, and we'll try to brainstorm on the topic and come up with some recommendations. Thank you.
Can we have that last slide with the table? There we go. That's the one I want. In order to save some time here, why don't we right now take a pause and find your table and go to your table, and then we'll hear the next 5 to 10 minute talk on advances in physics-based and AI-driven model and forecasting, and that'll be given by Dr. Luca Della Monash. But right now, let's go and find the tables you should be at, and we'll have a few minutes to do that, and then we will pick it up again. And Luca, you can come up here, and after Luca, it'll be Roloff. You'll be giving yours, and then it'll be Stephen Sims, and then it'll be Prasant Marpu. And if you see please just follow after Luca. You can just come up here yourself, I don't need to introduce every one of you, and we'll just save a little bit of time if you just come up here when the previous 5 or 10 minute guy is done. So otherwise I'll have to come up here and introduce you.
For other audience members not listed on the slide, please join whatever table seems most interesting to you. So if your name is not up there, don't panic. Just join whatever table you're most interested in. Thank you.
He already said it? Okay, I said it in the beginning. All right. So I think we're kind of getting there. So please try to find a table. The chairs are kind of heavy, I guess. Okay, good. Luca, why don't you come up here and give your presentation on advances in physics-based and AI systems.
All right. So the next topic area is in regards of advances in physics-based models and AI and machine learning modeling for forecasting and how those might relate to rain enhancement activities. So what I'm going to do here today, just going to show a few slides highlighting some of the main topics on this area that could be relevant for rain enhancement. So first of all, when we talk about physics-based models, as many of you know, those have been improved progressively, constantly with research around the world in the last several decades. And we have witnessed improvements in the data simulation system, in the numerical procedure. A lot of work has been done on the physics packages. We have during this forum these days, we heard of several activities towards the improvement, for example, microphysics schemes. And this system, they keep improving significantly also in terms of resolution. For example, the European Center, which is recognized one of the leading centers around the world, it's about to double the resolution of the ensemble system, which includes 51 members from about 18 kilometers to 9 kilometer resolution. That's global. And that's really exciting in terms of advancement in terms of a physics-based model. At the bottom here, also showing some of the work we're doing at our center, the Center for Western Weather Water Streams, which is part of the Scripps Institution of Oceanography at the University of California, San Diego. At our center, as many other centers around the world, we are developing a regional capability. In this case, we are trying to push the envelope in terms of probabilistic prediction, where we are generating a regional system prediction at 9 kilometer resolution, and we are creating 200 ensemble, which is, again, it's unprecedented. The reason why that can be useful is because when everything else is equal, having a higher number on sample allows you to better characterize details of the distribution. That can be very important when there is interest in extreme rare events, as that could be related to rain enhancement activities. Now, physics-based models are wonderful tools that include the best knowledge that we have about physical processes, numerical procedure, etc. However, as we know, those are contaminated by biases and conditional biases. So one of the things we can do with machine learning in a post-processing framework, that we can use the estimate of the dynamical model as a springboard to further improve the predictions. You can do that by looking at an historical data set where you have both information from the observation of the quantity to predict and the estimate from the dynamical model to learn how the model behaves. and characterize the errors, the typical errors that the model has in its estimate, so that when today you have a prediction, you can actually estimate and reduce some of the expected error on that prediction. On this example here, I won't go into the details, but you see on the upper right a CRPS skill score, which the higher the better indicates the ability of, in probabilistic terms, of different systems to predict precipitation from lead times from day 1 to 6. And what I want you to focus there, for example, the green light, that is ECNWF, which is, again, is the leading center around the world. And the dashed line represents an estimate built with a deep learning algorithm built on our 200-member ensemble. And you can see we are improving significantly the ECNWF on top, which, as I said, it's already a pretty good prediction. So there is an opportunity here to use machine learning to significantly improve the estimates of the dynamical models. That's what we're doing actually with our project for the UAE REP program. Another important aspect of machine learning method, which I think has not been really explored for rain enhancement activities, is the fact that these algorithms can actually be used to better understand the underlying physical processes. On this example here, which is, I don't have time today to go into the details, but you can find in that paper led by Peter Gibson, mentioned on the bottom right, a random forest algorithm has been implemented to predict the precipitation anomalies at the seasonal scale, to make seasonal predictions. And not only these algorithms create a skillful prediction comparing favorably with dynamical models and other statistical methods, but also allow you to understand the, you see at the bottom there on this graph, the mean minimal tree depth, which is basically gives you the importance of different parameters. And with that, you're able to gain insights on what are the dominant processes for the predictant that you're trying to estimate. So for example, in this case, for the prediction of precipitation anomalies over the western US, we found that the tropical Pacific SST is actually the most important predictors, followed by the western Pacific SST, and so on and so on. So similar approaches can also be used for rain enhancement kind of application to gain insights into the nominal physical processes. Another important thing that I would like to underline today, which I think it's an exciting development in machine learning, that here I listed two very recent contributions that now data scientists are actually developing weather predictions that are not based on model in real time. So the machine learning algorithm is used to learn from a model, in this case from a reanalysis data set. Some of you might be familiar with the IREF that is provided by ECNWF. What this model do, learn from several years of data on an hourly basis, the main relationship between the different variables of interest, in this case can be winds, humidity, temperature, pressure, etc. And they've been shown to actually provide, at least in a deterministic sense, very accurate prediction, better than CNWF again. Now, those cannot be really called model-free predictions because they use the model in the training phase, but the actual forecast is generated without a model. And the advantage of that is that the prediction can actually be generated in milliseconds. And so once again, this algorithm can be used to generate several replicas of the prediction estimate to span the uncertainties of the chaotic system that we're trying to describe. So this is it's a new frontier in machine learning that I think is worthwhile to consider for help with improving the operation, the rain enhancement operations. Those are just a few thoughts that I have for you today. I'm looking forward to the discussion on our table. There are many other areas that I think can be considered when it gets to model physics base and also machine learning, the development of machine learning algorithm. Thank you.
Good afternoon. I just had to look at the clock. So I want to talk a little bit about field airborne campaigns, observational platforms, and unmanned systems. We have talked a lot about instrumentation, and there's been several presentations on observations and using certain instrumentations. But I'd like to go show a little bit of that, but then also about observations that we haven't heard about in this meeting and what we can expect potentially in the next 5 to 10 years that could potentially help us in understanding this. So I'm going to talk a little bit about the airborne in situ sensors and remote sensors, surface in situ and remote sensors, including weather radar, spaceborne sensors, geostationary and polar orbiting that I can think of. There's a lot of other instruments, LiDARs, all kinds of other SODARs, wind profilers, you name it. There's a lot of instruments that have been deployed in the UAE also, but we also want to look at the future. In terms of some of the in situ measurements, these are some of the instruments that have been developed in the last 10, 15 years. This is sort of the next generation spec instruments, where we now have much more detailed information in situ measurements. The primary thing that I think, or one of the exciting things for me lately, is that we now can also carry a radar, a Ka-band radar, the KPR that you see on the screen there, which is upward and downward looking. So we get some information, and this has been on aircraft, but has never been really deployed in the UAE before, where combined with the in situ measurements, you can start looking at these radars. And these radars are developing, because not only are they Doppler, but in the future I think there will be dual polarization, which can give us individual particle information. So those are really important instrumentation. Here's an example of all the instruments on the aircraft. Basically, I'm not going to go in detail. I think the group can think about what we need to develop in that regard and what needs to be refined in that regard. But here's an example where we combine the in situ measurements really with the radar measurements. And these are sort of examples from a field project not here in the US, where we basically from the 0 degree level to -17 study the ice process. And basically you can see the radar signatures together with where we did the penetration and the particles at those different levels. And you can see how the evolution from large drops and the number of large drops, those are important in terms of the precipitation processes, really point to the first part, develop into ice particles and potentially secondary processes, secondary ice production processes. So these are really important. Coming to radar, radar has been used. We heard a lot about Titan in this meeting here so far, but what I didn't hear a lot about is the capabilities, and we haven't really utilized that, of dual polarization. Because with dual polarization, we can go down, identify certain particle level, identify potential large drops, and also in terms of potentially secondary ice processes. And here is just an example of all the wealth of information that we are getting from this. These maps basically just shows reflectivity, winds, precipitation rate, particle identification, and combining this with the aircraft observations. And this is what we hope and plan to do in the airborne measurements this year also. But I think really we need to start including dual polarization type of data also. So I really want to incentivize also that we think about what have we not been using. The other important thing that I think is we need to use integrated system, unmanned, manned, surface observations, bring all these things together, because that will give us the full explanation or the full understanding of the whole system. So really integrating observational system. Here's an example of just some work that we have done in terms of from a dual polarization point of view, and I will not go into detail. ZDR at the bottom is basically differential reflectivity, and this is effective reflectivity. This was work that was done in Australia. But you can see on the right-hand side, the red dots are basically all scattered all over, while on the left-hand side, not. They are coexisting with the blue dots. And what this basically means, this is raindrop size spectra, that those are continental clouds on the right-hand side, maritime clouds over here. So in the aircraft observations, we also find that we get different amounts of large drops, but this can give us an indication of how continental, because then you get fairly large but few drops, and so radar can help in these kind of things. And I think these are the kind of measurements that we can potentially include. Going to satellites. There are more and more satellites going up sometimes I think every day, rockets these days, and they're going to go up more rapid. Actually, the first of a constellation of X-band radars by Tomorrow I/O will be launched this year. And in 5 years, we will have a constellation of X-band radars in space. And this not only relates to radars for precipitation processes, but there's other instruments on the satellites in terms of aerosol, in terms of cloud characteristics, that I think we really need to look up. Meteosat has sent up a new next generation satellites. The US, the GO satellites have the next generation. Himawari. So I think these are important components. How do we bring all this together? Because not only from a regional but global perspective in understanding the different systems, because this can feed back in terms of the observations for the modeling, because we need to keep the modelers straight so that what they simulate really happens in nature also. And I'm thinking of Lulen. No, I'm joking. Anyway, so this applies not only to our work here in terms of the rainfall enhancement, but it's in climate variability and change, Earth's surface inferior, weather, water energy cycle. So the data that comes out of these satellites nowadays, and actually is going to increase exponentially. And yes, you have to be selective in terms of what you are going to use, but I think those are the kind of things that we really need to look at in terms of the future also. I'll just show one example. This is an example by some recent work in terms of red pixels are forecasted for convective instability locations in the next 60 minutes. So if we combine this with some of our algorithms and utilizing this, and with satellites becoming more and more, especially if we have a constellation of X-band satellites, X-band radars in space that covers the whole world, there can be great regional aspects also. So I just want to stimulate your mind in terms of thinking outside the box and outside of what we've been doing in terms of the measurements, but specifically as it relates to precipitation processes, and then how can we apply this to the rainfall enhancement. Thank you.
Well, thank you. It's very happy to be here. And Richard, thank you for explaining the rules to me. I'm happy to learn them now. But we're tasked, our table's tasked with evaluation. And honestly, this is the bottom line for a lot of this work. So it's a very important task. We need to figure out how things go along. And rather than go to pretty pictures, there have been a number of recent publications and essays out there, and so I've went a different path down here. And an essay that just came out last year, just a couple of months ago, basically off of the glaciogenic seeding in the western United States, though, had some interesting points about the significant progress in observational and computational capabilities. And we've just heard so much about that with the satellite capabilities, the radar capabilities, dual polarized radars. We've heard about machine learning. We've heard about artificial intelligence that we can use to help improve forecasts and to evaluate. And then going on, we need further process level evaluations combined with highly resolved, well-constrained numerical simulations of seasonal cloud seeding. So moving it up to a basin level, moving it up to a regional level to quantify it. So we need to go from individual process level, we need to scale it up to a regional level to get our impact. And just the year before this was Taha's paper evaluating the historic program here. And I think there's a lot to be learned from this work also, working with the NCM, that provides new insights into assessing long-term seeding impacts and the capability of working with this, well, evaluating at this scale, again, to hopefully quantify our work, quantify results, get some kind of measure going on. And then I'll go back, serve on the WMO expert team on weather modification, and not too many years ago, the panel had worked on an evaluation of weather modification, largely sponsored by the UAE. We are very grateful for that support. And in the evaluation section, there was an exploratory studies that are needed to document the processes associated with natural precipitation in the region of interest. So again, emphasizing the importance of going out and understanding the natural precipitation processes. If we want to understand our impact and be able to observe our impact, we have to understand where we start at. Before a catchment scale experiment is undertaken, historical data should be analyzed to estimate the probability of detection of enhanced precipitation. If we want to go on to that level, we need to do our homework. And then, important going on, a randomization of seeding and a consistent methodology are essential to support a rigorous statistical analysis of the data collected during the experiment. So I think, in all of our proposals, we need an evaluation strategy. I think our table, probably since I'll be giving the summary, you'll see that when we give the summary that we want to see the proposals that come in have an evaluation strategy as a part of the proposal. So, just going through some of this, and we could go on, but I think these are, and I apologize if I've overlooked some papers there, it's not my point, but getting to some of the points involved, there are different levels of evaluation, different parts we want to look at. Statistical empirical evaluation, it's going to be critical, but a process level evaluation, physical evaluation, and then also some work with where are we at with numerical simulations? How efficient, how much confidence do we have in using numerical simulations for an evaluation purpose? Getting to the statistical empirical evaluation, when is it too expensive? When does it require too much time? Is it reasonable across multiple seasons or across different time periods? We always have to address that question. Many years ago, I did some work with the Tasmania evaluation, and certainly those questions arose consistently. Process level evaluation, physical evaluation. Well, again, we need variability. We need to think it out for the methodology. What we use for looking at acoustic methods, the Chinese have presented here, versus when we fly with an aircraft and we use hygroscopic seeding or we use glaciogenic seeding, we need to develop efficient evaluation methods for these different techniques, for these different methods. And can the full precipitation process be observed? Can we get down to seeing this evolution? One of the, I think, really impressive things about the glaciogenic work in the western United States, and we heard that before, Mohammed gave a nice presentation about that yesterday, what was seeing the whole chain of events from the physical processes to the physical results on the ground. And I think that really inspired a great amount of confidence across a lot of the community that we can get to this level. It's going to be obviously a much greater challenge for convective clouds, but these are some of the things we need to focus on. And then there's more and more work we're aware of where evaluation is done via numerical simulations. I know in Australia they are hoping to do much more work on the evaluation of their efficiency with numerical simulations in the Snowy Mountains. And this is heavily dependent on the microphysics within the schemes, but also the observations, the control simulations, and where are we at with ensemble approaches? So how far along are we with this kind of work? I think that's my last slide. So that's all I have, and hand it over to the next table.
I'll be very quick, I'm the last one. So here we are talking about technology readiness level considerations in this field. So the program, go to the next slide. Sorry, I can do this, sorry. So the program clearly has been a very successful program and it funds research projects that yield science-based solutions for rainfall enhancement. And as a guideline, at the solicitation level, the program already expects that the successful proposals will have a good understanding that the solutions that are proposed or solutions that are being developed follow some sort of technology readiness level progression, and the models that are going to be developed are expected to come into operations at some stage. So we have to have some sort of articulation of different levels of progression with respect to the technology readiness, both in terms of technologies that are developed, hardware or technologies, and software or models developed, basically. Just to give you a bit of examples, the concept of TRL was pioneered in the early 1980s by NASA based on their space program. So it basically gives us some levels all the way starting from the concept, idea concepts, to operations and deployment through a progression of steps which are defined at different levels. In this program, the expectation is that the rain enhancement program, the solutions that are developed through this program are expected to be around 5 to 7 in general. No? It's not a rule, but a guideline in terms of expectations. And this roundtable basically is all about looking at how far we are in that progression and what has to be done in terms of enabling a proper progression towards operationalization. This is a very beautiful summary that the NCM team has put together in terms of what happened in the previous programs and some examples of which technologies reached different levels. In this case, now it's like the cloud seeding material already reached deployment level things, and once we get heritage, it's ready for commercialization. The unmanned aerial vehicles and cloud formation system, jet engine system, basically are at technology demonstration levels, not development. Late stages of development and early stages of demonstrations. And the cloud chamber is still in very early stages of the development, as an example. So now, the general questions we keep on asking, we should be asking every year are, what is the roadmap of future development, considering how far we reached till now? What are the gaps identified based on the past projects that will help the roadmap? And now, the final question which our roundtable is expected to answer is, where do we stand with respect to inducting results of the existing projects in current operations, or even for the future now? So we all know that, it's like these are some of the considerations. The applicants are not only expected to develop solution, but also are expected to provide a path towards qualifying and validating the technologies to expect operational services through them at some stage, not immediately within the program duration, but at some stage eventually. So now within that, can we look at some sort of targets for future grants based on the experience we got from thing? I'm not saying that we have to find answers today, but these are some of the questions we want to place there for consideration. There are two types, of course: software solution development based on models or things like that, and hardware technology development. Is there a way to measure return on investment beyond contribution to scientific advancement? So that's, in the end, that's the final goal as well, to get these things into operational environments and see how they're going to help the programs, right? So when we're talking about work that is being done in the grants, let's say software solution development as an example, or model development, what is the expected maturity of the solution to support NCM's operation at the end of the program? We take it as a baseline, say by the end of the research grant, basically where do we stand? Now, that's one thing. And then, are there any components? It's when you are doing any research, we all know that we are working on certain topics, but there are components that will be developed within those programs which are suitable for commercialization outside the operations of NCM type organizations. So can we identify those things and have handover of those things to relevant organizations within UAE or elsewhere, or to the commercial sector to commercialize those things? Now, the same questions in terms of hardware technology development. So TRL7 is basically where technology is demonstrated. It's not at getting into the operational environment or deployment environment, but TRL7 means it's technology is proven and developed for demonstrations. Can we enforce, when you have a hardware or technology development project, basically, can we enforce TRL7 as a minimum requirement? Again, I'm asking a question. There will be constraints and a lot of things depending on the programs. But so if not TRL7, what is the minimum we can expect to have there? So can we also provide a plan for operational deployment of that technology? At least during the program, we have to start thinking about what is the level right now at the end of the program or during the program, and how far are we towards operational deployment? And now, again, the same question: what are the components developed in the program that are suitable for commercialization outside NCM's operations? Aerial vehicles, for instance, or all those things have applications outside regular weather-related programs. So can we look into those directions? It's a proper validation of the program's return on investment as well, right? So these are some of the questions. So now, and then the second topic we have to discuss is now from NCM's perspective. There are solutions that are being developed through the research programs. There's very active research going on in all those things. And some of those things start coming into the operations of NCM. So someone should handle this thing. So should NCM develop a dedicated in-house development or applications team, or try to onboard local industry? That's one of the questions. Now, this is where the ecosystem development can happen. But there's another question: what is the maturity of local industry to support operations of NCM? So you need to go back to the roadmap, see what happened there, and which type of industry that is available locally within the UAE is capable of doing that. This is a very important feedback NCM has to provide back to the government to enable some sort of local ecosystem development. And both in these things, now developing in-house things or giving it to commercial industrial partners, basically what are the advantages and disadvantages, and how do we go about articulating things? Now there's no unique solution. You need to come up with joint collaborative opportunities between industry and the NCM here. And these are operational considerations. Now if you go to the commercial considerations, so if we do not have enough maturity in the local industry to support operations of NCM, and if we go about onboarding some of those things, basically, there's also some initial support the local ecosystem needs towards development of certain technologies, or towards familiarizing with the technologies that are developed through the program, or basically get trained on support operations. For example, a new drone comes into the picture, basically a company, for example, my company like Banath can take over the operations of the drones continuously and be responsible for that division. Don't take it literally, but that's an example. So that type of things handled by local company will kind of ease out some of this burden from NCM while they focus on actual work, but there's something handed over to the ecosystem to work on operations. So, of course, we also need to look at what is the level of interest from commercial companies locally. Will they be looking into, because traditionally most of this work within the UAE was not done at industry level or any commercial companies. So how do we onboard them is the other question as well. So these are some questions we wanted to put there and get some answers and summarize, at least at high level today, and eventually pose this as questions for continuous thought as we move forward. Thank you.
Okay, now we're going to get to work. Those are a lot of really good questions. That was a great sort of summary of where we stand and what's in front of us. Now we've got some really great questions. Let's get some great answers too. and you'll have like 45 minutes, and we'll run a little bit into the lunch hour, but that's all right. I'm going to give you all 45 minutes, and with about 5 minutes to go, I'll come around and remind everybody there's 5 minutes to go. You'll see there's a flip chart over here if you want to summarize some of the most important findings as you go, or you can just wait until later. But if you want to do it now, that's probably a pretty good idea. But so 45 minutes or so, and let's see what happens. Good luck.
Hello, everyone. Yusuf here. Sorry to break it up, but if we can continue this over lunch, that would be great. Feel free to stick with group members on your table during lunch, just in the next hall, and we can continue the discussion after lunch when the team leaders will wrap up, make a summary of the discussions, and present them for us. Thanks a lot. It's great to see everybody still sticking around, but I'm sure there's some people that are very hungry as well. All right. See you at lunch.
let's go back to our tables, and we can start. Because I think we've got some really pretty interesting recommendations coming up. Is Duncan here?
Duncan is on your right.
There he is. Duncan, do you want to give me your results?
Okay, so our group is sitting right here. We have a few missing. We had Martin, Ali, and we have a group from Romania that are involved in haze suppression, Khalifa University, and Sufyan. So I'm going to read this again because one of the things was that we struggled with what we are charged with, innovation in rain enhancement and cloud formation systems. So innovation in rain enhancement, innovation in cloud formation systems, and technologies. When we first started our discussion, we started to focus on the process, on the proposal process, and trying to come up with ways to make the proposal process more attractive in order to innovate in these areas. So that took quite a bit of time, and we came up with a few ideas, conclusions, recommendations. And the first one was to continue to combine innovation, experimentation with operational deployment. So the concept, the idea here is that the innovation should have not only the operational application, but also the ability to be deployed in the operational setting. Martin, did I capture that very well? Maybe you can elaborate a little bit.
No, the elaboration only mainly being that we shouldn't confuse deployment with the operational services as something that has proven to work. We need to be able to have experimental and novel ideas to get close to operational things without having gone through these pre-phases of this must work and that must work and that kind of thing.
Yeah, and I think we also discussed the TRL level, and which is, I know there's another group that's focusing on that, but just because the TRL level is low for a particular innovation, it doesn't mean that we shouldn't try to lower the risk of experimenting with that particular idea, just as long as it fits in the operational deployment of that innovation. So we provided examples, and that previous experiences were discussed around that. Related to that, the next thing that we touched on was the concept of determining what has not been done yet that will push the science forward. So what are the aspects of research that haven't been tested, experimented with in not only in the previous awards, but also outside of this award, that are needed to push the science forward. And there's a few examples here that I'll go through in the end. And another aspect that emerged from this group is the need for a framework that continues to advance the innovation that was created through previous experiments. So there's been a lot of work done by the previous awards. There's been initial experimentation and initial findings that have been achieved by those previous awards, but there's limited time to advance the innovation within the period of performance. And I think this is expanded on, yes, it's expanded on in the next point, that the experiments are linked to a fixed time frame of 3 years, and the period of performance that is established in the proposal. So the feelings of the group was that this limits discovery and progress of that innovation. So the recommendation is to have more flexibility in the time required to advance the discovery forward, to make further progress towards that discovery. So more flexibility in the time frame of the experimentation. Then the next point was this idea of cross-team collaboration amongst awardees, which has been discussed in previous iterations of this activity, but it came up again. There's several innovations that have been done by isolated teams, and providing a test bed for these teams to come together and do research together to further progress in that innovation. And some of this, we're seeing some examples of this already, where teams from previous awardees are coming together and advancing the research and the innovation further. One idea is to actually create a separate call that focuses on that, where we're more focused on enabling this type of cross-team collaboration. There's pros and cons to that. The group suggested that doing it separately may actually be a detriment, because it's not competing with the new ideas that are coming in. So there's pros and cons that need to be explored a little bit further. But cross-team collaboration to amplify the impacts of the research and the innovation could be a focus that advances the innovation. Now, focusing more on the technology aspects, and this is where we're going to launch and maybe getting a little bit more creative with our ideas. One technology aspect that we think needs to be further developed is the detection and quantification of the seeding effect within clouds. There's definitely a need to be able to develop technology that can track seeding material once it is ejected in the cloud environment, and to be able to track how it's mixing within the cloud, so that when the in situ sampling of the seeding material is conducted, there could be certain confidence that the detection of the microphysics is being done in the area that is being impacted by the seeding. So any technology that can be developed that can detect how the seeding material is mixing within the clouds could help with defining a seeding effect. What does a seeding effect look like? And that would help with, for example, modeling it then within models that can define what the seeding effect looks like, because in models we're assuming what a seeding effect might look like. So detecting and quantifying the seeding effect so that we know that we are in a region that has been impacted by the seeding, and quantifying what that seeding looks like. And then another area which emerged as a gap in technology is that we have to design seeding experiments in a cloud environment that enables this detection of the seeding effect. For example, conducting experiments in convective clouds is highly complex, and the ability to detect that seeding effect is also difficult. So can we either create a cloudy environment that is more stable and then perturb that cloudy environment by the seeding, is one idea that came out. Another one is to conduct the experiment in a cloudy environment that is easier to sample, easier to detect. Orographic clouds is one example of that, or stratiform clouds is one example of that, where you have a more homogeneous type of cloud or more predictable cloud that is not as complex as convection. And related to that is developing the technology that creates a controlled cloud system. So if you're able to have technology that is creating a controlled cloud environment, then modifying that controlled cloud creates an easier experimental setup. So kind of adapting the cloud chamber idea, but in the natural environment. Now, there are cloud chambers that are portable and that could be deployed on the site where the experimentation is being conducted. For example, continuous flow diffusion chambers, where you don't have a static cloud system, but rather a continuously flowing system, is technology that already exists. So those are the ideas we came up with. Certainly a topic that could take several directions in terms of the innovation part, in terms of the rain enhancement and the cloud formation aspects, and the technological aspects. Did I capture the spirit of the conversation for the group? Okay. Thank you.
Good. Thank you, Duncan. I was going to wait for all the questions at the end, but I think maybe we'll all have forgotten what the guy said if we don't do it right now. So I'll at least like to take one or two questions after each table makes their presentation.
Yeah, thank you, Duncan, for the summary and the suggestion. I think some of the points that you just mentioned has been done in other kind of a different environment and experiments, such as the tracer technique that you want to identify the seeding, kind of the cloudy region area and the information on the surface in the snow or in the rain water. So tracer technique has been used for wintertime orographic cloud seeding already. So releasing the seeding material at the same time release another similar size distribution of inert aerosol. So you can actually track and compare in the snow sample to really identify the region and the area being impacted by your seeding material. And even further, you can really measure the concentration of the silver mass within the sample to compare with the background silver to really see, okay, how much potential water can be increased by that. So I think some of the work have been shown these type of successful experiences. So I appreciate that we can extend that to either more scenarios of cloud seeding application. And I think you also mentioned the simpler cloud as a natural laboratory similar to the cloud chamber. I totally agree, because for us, we also think about targeting some very stable marine stratocumulus type of cloud to really see obvious response. But of course, like ship track is already a demonstration of the impact of aerosol and cloud interaction. But then seeding is more a human kind of in purpose, the kind of action. So everything that you mentioned, I would agree, but just saying some of those have been done, so we can actually borrow and learn from those.
Okay, I don't want to take up too much time. Does anybody have a burning question? I actually do, though. Can I go back here? The one that says continue, is that the beginning? Continue to combine innovation experimental with operational deployment. Now I know that nanomaterial certainly is an example of something that was done, but I just like to know, maybe from Safian, what actually is the process for going to do that? I mean, how do you actually take your innovative idea or your new model or whatever you have and get it into operational deployment? How are you going to go about doing that? Is there a process? Oh, wait, hang on.
Martin, yeah, I think could be directed to you. Perfect. Yeah, because
Oh yes, yeah. So I mean, the concern was more whether, because I think a lot of us understand the need to be close to the operational department for our research to be important, and so my personal concern was, are you still able to use innovative and unproven techniques to do that? Now, for example, I think the stuff that we are doing with ionizing flares and that kind of thing is one example in which that can work quite well, and NCMF. So.
Yeah, as this is suggested by the new proposal that to enhance the properties of this aerosol material to boost the rainfall amount and so on.
Okay. I'm going to just have one more on this, and then I'm going to move on. Sorry, I'm limping around.
Thank you. I'll be short. I think there's this process of co-design that has been developed in the scientific community in the last decade or so, where there's an appreciation between the operational people and the research community and awareness of limitations and requirements from both sides. So it's really important when something that might have operational application is designed in such a way where the operational people are actually part of that process, so that it's well informed, so that you don't develop something that doesn't fit into the operational scheme. And I think, Martin, the example of developing a flare that fits into an existing rack where a hydroscopic flare would have sat is a very good example. But so there are many other things in terms of radar algorithms, the work that Roelof has done, on the same platform that's operationally used. I think those are the type of examples.
Yeah, actually, our table 2 here had much the same idea of maybe incorporating somebody from the operational side into the proposal.
Yeah, exactly. That would be a perfect way to move into the discussion we had at our table. That actually we have 6 practical recommendations. That one is number 6. Exactly, we discuss similarly to what you guys brought up, is the need to connect the projects with the operations. And one way to do that is to have a requirement that for each project, on the team project, there is a member from the operational team of the NCM for the cloud seedings operations. So if that can be accomplished, it would allow a direct channel of communication between the research team and the operations to make sure that what is done, executed and developed during the project is online with the needs of operations. So that would be an idea on practical idea to facilitate the research to operation path, which connects to the TLR's discussion that happened on another table. Now, going down the list of recommendations that we come up with, when it gets to physics-based models, we recognize that there is a need to develop schemes that might be tailored specifically for rain enhancement activities. One of those might be microphysics schemes. We heard during the last couple of days there is already ongoing a lot of research directed at the development of microphysics schemes for rain enhancement processes. So that could be something that can be encouraged further the next call. And more importantly, one of the requirements should be that any of the development that happened during a project should make it back into the community model so that the community at large can benefit from the development that happened during one project. And again, this connects to the TLR level for the different projects. When it gets to AI models, it's clear that there is a need and would be very beneficial to have a test bed where different data sets that can be observations, can be numerical weather prediction data, can be grid data, can be point-based estimates, all sort of data that can be used to train machine learning algorithm to sit in the same place, possibly with the same format that could be easily accessible by the different groups to develop and test new ideas and new algorithms. So that would be very useful if would be in place. And beyond that, as part of a testbed framework, case studies could be selected so that when a team develop a new methodology, a new predictive capabilities, that can be tested against other methods that have been developed previously. And of course, as part of that, the verification piece would be very important. Again, this goes with some of the activities that have been discussed possibly at another table, but there could be a testbed framework where there is data set, there are case studies and verification routine for people to allow to test and compare and contrast what they develop against what has been developed previously. Another important thing that we discuss is, as a recommendation, could be to make sure that in the next round of call for proposal, it is allow access to the supercomputing that we heard is now available at NCM. There might be ideas coming from scientists from developing countries that can be great ideas, but it can be computationally intensive. And if those scientists do not have access to these resources, then NCM could make available both computational resources and storage so that this project could be executed on NCM machine. And that would be very important to foster ideas really across different teams around the world. Yeah, that's the number. Yeah, what's number 5 there? Maybe I'll have him to describe it. Yeah, that was number 6 already talked about number 6. So regarding the tools that can be easily applied and provided to developed countries, maybe you want to spend a few words about that? That was your idea.
Yeah, thanks very much. The idea is that in developing countries, it's difficult that you have enough staff, resources to conduct all these modeling and data comparison, and I think that's something we could actually deliver to provide developing countries and med service who do not have the capacities to provide tools that they can actually do the best out of them. There's so much data available, there's so model available, but we need to provide them tools, dedicated, tangible tools that they can use for their own purposes. So it's a kind of capacity development and involve, as you said before, give them access also to resources that they can perform their own analysis of forecasts. So it's a kind of providing the necessary tools that is developed and others do not have them, that they can move forward.
All right, thank you. And the last things probably I want to mention is that in terms of topic, research topic that could be listed in the new solicitation for proposal is the development of machine learning method to represent subgrid scale processes. This has already been done in the community. There is a lot of work on that direction for climate model to basically emulate physics packages with machine learning algorithms, which allows to execute this physics emulator in a much faster fashion than what can be done with dynamical models, which again also allow to generate ensemble prediction by running these systems in several different configurations. So that could be a topic of research. Again, the use of machine learning to emulate physics packages, specifically tailored for rain enhancement applications. And I think that's all I have for our group.
Does anybody have one question that they really want to answer to right now, or can we wait? Okay, well, I'm going to hand it off to Roloff then.
Sorry, I am doing a PowerPoint. Can you bring the PowerPoint up? Okay. So, yeah, we had an interesting discussion, and I think some of the themes come through here also. Excuse my spelling mistakes, because this was typed up very fast. I just wanted to do that. The first thing was measurement and platforms for operational programs. I think one of the most important things is really having accurate rainfall measurements, and I'll talk about that. Aircraft seeding measurements. We really need to know, and this is for ground-based and aircraft, location and time, and in aircraft seeding, the updraft speed. So in terms of long-term, there are many operational programs, and there's two ways to evaluate it. There's the models, but also in terms of having these operations to really look at that. Measurement platforms for research programs, looking at microscale processes and macroscale processes. And I think that's what I talk all about. Then also airborne sensor needs and challenges for different and piloted and UAVs. And then observations for decision making in seeding and measurements. We talked a lot about developing algorithms and developing measurements for seeding, but that could also be applied for your measurement program. So looking at the operational programs, accurate rainfall measurement fields, maybe real-time gauge-adjusted radar rainfall algorithms to get to the spatial resolutions, especially in convective environments. We really need a better job. There's the interaction between rain gauges that don't have the spatial type of things, but the radar have the spatial thing, but not the accuracy. There's biases. Even on seeding aircraft, sometimes we should think about updraft speeds and, if possible, basic state parameters. Also, in terms of the evaluation of seeding experiments in general, we need to think about regional scale, because some seeding effects may be experienced for longer periods. We have seen this, and this could go, especially in small countries, beyond their borders. So I think regional cooperation in this regard is maybe an important component also. Use of multiple aircraft or UAVs or a combination. We talked about maybe it is time to do an experiment with a piloted and a UAV. The initial experiments in the US, major experiments, even NASA experiments, use multiple aircraft. We cannot be everywhere with the aircraft sign. We talk about ice processes, we talk about warm rain processes. Maybe we should design an experiment with a UAV and at the bottom and a piloted aircraft. I think it was mentioned, I put a question mark there, a piloted aircraft cost is equal to 10 drones, because then you can also do much more wider seeding. Collecting relevant satellite and radar data. This is especially for the algorithms. And as we mentioned, there are new satellites going up, so we should continuously evaluate, can we get better information to even upgrade our decision-making algorithms, and also maybe the radar data. And one of the biggest recommendations and also a limitation is regulation for UAE flying. And here we're talking about not only the less than 50-pound payload, which are basically the small rotor things, but we talked about payloads of 50 to 500 pounds. If we want to do seeding, we may need about a 50-pound payload in terms of doing the seeding. And those categories, we need to talk to the authorities in terms of getting regulations in place to do the flying of this. We talked about putting transponders on UAVs so that they can get to the same level in terms of air traffic control and those things. So that is the biggest impediment, as far as I heard from around the table, in terms of utilizing UAVs in a similar manner than we are utilizing instrumented aircraft. So that is extremely important. The next thing, field campaigns. You know, there's testing physical hypothesis possible with multiple aircraft or combination of UAVs and piloted aircraft. Again, there we talk about, and here again, we have seeding material and the corona emitters, as we say, coalescence is increased. But if coalescence increased? Do we get more precipitation? We need to think about this whole physical chain of events that we really want to understand. And then especially evaluating new satellite and radar measurements for decision-making algorithms for seeding and measurements. I think these are, there's some new data now available that wasn't available 3, 4, 5 years ago that really should be accommodated. Airborne measurement recommendations needs instrument development. I think it was identified the region between 0 and 60 micron with the current scattering probes still have challenges. I flew in projects with 3 different scattering probes. They are all over the place. We really need to nail this down because many of our corona things, seeding of large particles, affect that range at the first moment. And in assessing that, it's really important in instrument development. There are work done by research at the moment, but that is a region which is really important in getting some really accurate measurements. New instruments such as the airborne radar, in situ measurements, upgrade to dual polarization. I think if we can get dual polarization on the airborne radar also, that would have a great, better measurement. Better sensitivity to detect smaller particles in cloud. I think here again, you go back to the small droplets. Miniaturizing instruments for UAVs, but with the same quality measurements. It's an extremely difficult problem. It's not easily done, but this is important for the future. If we are going to use UAVs, we want to miniaturize them because of the payload type of things. And there has been work that has been done in this regard, but I think this is an important component, and this could also be miniaturizing instruments for seeding aircraft. Like Duncan has said already, and maybe it's too big, maybe we can miniaturize it further, looking at some of the important parts. And then continuous data transfer between surface and aircraft to update information in real time. I think this is one thing that would be, and again, for our project this summer also, between aircraft, but also in terms of aircraft to surface, so that data is available in real time wherever we work. Observational needs general, there was the comment made that we, in all these things, in terms of keep into account climate variability, climate change trends, and the rainfall enhancement experiments, larger scale measurements of satellites and radar will remain important. Does anybody of the group want to add anything to this? If not, I'm open for question or the next speaker.
Anybody have a particular question they want to ask this time to roll off? You know, that squiggly red line underneath the words means the spelling mistake. So, okay. But anyway, that was really a nice presentation and very clear. Okay, next we have Steve. Sorry.
Thank you. It was very interesting to hear how so many of these other tables have focused on evaluation and advanced techniques, methods, and needs for evaluation. And, you know, our primary focus was looking at evaluation. And the basic principles have been well known for evaluation, obviously for decades, going back to the earliest cloud seeding trials, that, you know, we need to go out there and we need to demonstrate every single step of the way, from our physical interference down to precipitation on the ground. And I think, you know, we had a breakthrough in the Western United States with the glaciogenic seeding and being able to demonstrate those steps along the way. Having said that, you know, this is a very challenging process. The evaluation does need to respond to the actual technique, whether it's glaciogenic seeding or hygroscopic seeding or electrical effects or acoustic waves. We need to be adaptable, flexible for what we're doing, and we evaluate those initial steps. And again, what has been mentioned, we need to take advantage of advanced instrumentation observations, whether it's radars, dual polarized LiDARs, whether it's, you know, advanced AI forecasts of what the precipitation should be. We need to start using these technologies, these advanced capabilities where we can. And yes, we should be looking at numerical simulations, not as a definitive answer, but certainly they can help us understand some of the processes going on beyond what we are observing, looking more widely at the environment or what kind of effects are going on there. But all of these things are not new. All of these things we are already well aware of. And we know the analysis needs to be done across both temporal and spatial scales. You know, we need to be sitting there, and if we're working on seasonal rainfall, we need to be analyzing at that scale. If we're looking at individual storms, we need to be analyzing at that scale. We need to be sitting there and taking a look at our physical scales, our spatial and our temporal scales. And also then, ultimately, we need to be getting to the point where we can demonstrate an economically valuable response or result. I mean, we are doing this to have an impact. It might be nice to sit there and make individual changes in clouds and demonstrating we can change clouds, but we've known that for many, many decades. We need to be able to demonstrate an economic or a society valuable response to our efforts. So, following the WMO statement, following statements that have been around for decades, it is a prerequisite to understand precipitation in the natural environment when designing a campaign. We can develop a well-defined physical hypothesis, well-defined methodology, criteria for seeding, and then we can proceed with a randomized trial. And a well-designed randomized trial is essential. It's you know, for our confidence, for quantifying the results. These are all worthwhile, necessary steps. And we can focus on the you know, having this background information can help us define targets and control areas that can help us look at extra contamination. Again, build a better designed program. And then also when we transition from research to operations, a randomized seeding trial should be maintained. Randomized seeding should be maintained even in an operational program. We would strongly encourage that. Having said all of that, and with our 60 years of knowledge in weather modification, we know that's incredibly, incredibly challenging to design a program like that and demonstrate positive results. We haven't learned anything new that way. We know these basic principles and we know the challenges. I think one of the really interesting conversations we had around here was, can we do more with the historical observations? Can we also look at more new analyses? You know, developing a big database, a metadatabase of cloud seeding operations, maybe not just in one location, but from around the world. Maybe we can develop this not only at the target or the catchment level, but also looking at this at the radar level if we're looking at convective clouds. And then we can use some more advanced statistical techniques to try to tease out environmental factors that may be important or operational methods that may be important. And, you know, possibly we can gain something looking at this historic data that we've overlooked before, that we've never had the opportunity to look at before. And then we can also see what can be done with machine learning, absolutely. See if we can sit there and tease out these important factors. And once we try to tease out some of these advanced tech, these factors, maybe we can get a predictive model designed. You know, we should be able then to quantify our results a little bit. Well, hopefully we can quantify these results with a acceptable amount of confidence for the policymakers, decision makers to act on. So I will check to see if I've spoken fairly for the table. Any objections? The table applauded. Okay, well, no. I'm happy to take questions.
You're not?
None? No?
By the way, I really like the historical data idea. That's really good. Any other questions?
Just want to hand the microphone to me, I guess. No, but Steve, thank you. Looking at the historical data point, very valid point. Because even for a snowy project that we have we claim we have 3 cases of very clear, distinct seeding signals being observed by radar. And actually after 3 years of the project has been wrapped up and we have students still analyzing different data, and suddenly when we look at the CAPI radar data, we found IOP1 show very distinct seeding signals. That is just want to say, when you look at the data in different ways and try to revisit some of those old data, you probably can actually discover very unique and very useful signals. So this is just a I would say testimony for your suggestion.
Thanks, Lynn. Okay, one more table to go.
Thank you. So this table was by far the smallest one, so we had a very quick discussion. There were more questions than answers on this table, so I left the questions that I posed in the slides and will be shared. But it was also good to see the other tables actually looking into some answers for some of the questions I was posing in the earlier presentation in terms of operational requirements and embedding and guiding the research towards operational requirements. So I'll probably just give these points as guidelines rather than answers to some of the questions that we're posing here. And then suggest to keep on having this discussion to get further answers or a bit of roadmap on that. So for the research grants part, it's like there is definitely a need that was also addressed on the other table to have an overview of the state of the art and identify the gaps in research. Also, we need to consider the research that was already conducted in all the existing research programs and the completed research programs as against the desired outcomes in those programs, what has been achieved against the desired outcomes, what are the gaps there, and what are the gaps overall towards fulfillment of operational goals, for instance. This was the second point we have is integrating feedback from existing operations program, enhancement program, to develop a research roadmap for operations adaptation, which is also touched upon at the two tables there on how to embed people from operations into the research programs to actually have that research roadmap from the beginning. So there were a couple of suggestions here, no? So for the technology adaptation roadmap, basically to take those solutions that were developed or under development into the operational environment. So if there are solutions at advanced TRL levels, we probably need to have a separate enablement grant program for just for commercialization or for deployment validation, basically. Or if there are, based on the current operational requirements, if there are certain things that have to be done for sure, we need to design a roadmap with time-bound TRL goals, that's the constraint, with and guide them through the program with bridge grants so that they come up to the first point I was talking about, where they'll reach higher TRL levels, and then they'll have their own enablement grants for commercialization and deployment. These are the two suggestions. And then the question I was raising regarding putting TRL requirements in the call for proposals is counterproductive as expected. But probably the other thing, taking requirements and having this time-bound TRL goals might be a better solution there. For the easiest thing probably is some of the software solutions that are being developed or were developed, or some of those algorithms that were developed, if we can look at pilot scale deployment of some software-based solutions that are promising, like some examples we had from Luca's program or from Rolof's earlier program, to set up at a pilot scale, set up in the current operational environment and see what is coming out. This will help develop guidelines for operationalizing the solutions in the future. No? That's one thing. And coming to the operations part itself and involvement of private sector or commercialization, basically, enabling private sector involvement can enhance faster adaptation, but and also faster adaptation of innovation as well, because the responsibility of innovating will be shared between many sources, basically. But this will come at a cost for the government or NCM in this case. But it is important to identify certain technologies or areas where NCM can enable private sector and push them towards being involved and gain a bit of momentum there for ecosystem development. But the significant part of the operations and leadership should be at this stage or in the near future should be in-house at NCM, as they are the only one who have heritage at this stage in the country. So these are some of the observations summarized here. I'll also share the slides with NCM. And I'll keep the rest of the questions as it is because they have to be discussed for a very long time.
Are there a question or two for Prasant? If not, I know there's at least one person that wants to make a short presentation that's of interest. And Tara, you're it. So if you can all just listen to this presentation. Oh, one last thing. After this presentation, we are going to have a group picture. Nope, I don't want it. The doors are locked, you can't get out. No, that's not true, but there will be a group picture after this, and then there'll be a few final words from NCM.
Thank you very much. May I have my slides, please? Thank you. It has been a very enriching experience to come here and talk to all of you. I have never been in a forum where only cloud seeding and weather modification has been discussed. And for the first time I'm here, and I want to thank the organizers for this excellent opportunity, and I'm very honored and privileged to be here. So this is my institute. I'm coming from Indian Institute of Tropical Meteorology, Pune in India. The star location there indicates the location of my institute, Pune. And I am currently the project director of Cloud Aerosol Interaction and Precipitation Enhancement Experiment. May I have the second slide, please? Oh, okay. Yeah. So in our institute, basically, we study Indian summer monsoon, basic research and development of models from climate change research to monsoon mission, air quality modeling, and basically we study tropical clouds a lot. It has very much resemblance to some of the clouds over the Arabian Peninsula. That's why also I'm talking to you. So our programs are this way. There are a number of initiatives, and basically our interest is to look at the monsoon variability and the cloud processes. And as you see in this particular figure, there are a number of regions where very less rainfall is received. For example, the region where I have indicated as Sholapur, that is a region with very less rainfall and which is a rain shadow region of the Western Ghats. We indeed have conducted a major field experiment, a field experiment named KIPEX. And this experiment started in 2009, but in the 2018 and 19, we have conducted a major field campaign with the various instrumentation. And the major objective was to look at the possibility of cloud seeding and the precipitation enhancement over this region. And this project was supported by the Ministry of Earth Sciences, Government of India. And we have several collaborators in this from around the world. So I just want to brief you on the salient features of this particular experiment, so that maybe something can be taken from our experiment for UAE also. So basically we have investigated the background thermodynamics, surface fluxes and cloud properties. We have a surface observatory which started in before the seeding experiment, and we've collected data on that. And then in the experiment we have characterized the aerosol, background aerosol, as well as the seed particle spectra. We also did hygroscopicity measurements, CCN activation, ice nuclei activation characteristics over the region. Then we did the physical experiments with the in situ measurements with the aircraft. We had 2 aircraft and also the radar observations. We made particle by particle measurements in the clouds, as well as cloud precipitation physics measurements and cloud residue measurements. Basically, we have done this cloud residue measurements using special inlet, CVI inlet, where droplets are evaporated and then counted. So we could also do the chemical characterization of these particulates. So basically, I am very proud to say that we have nearly 5,000 plus cloud penetrations done in the monsoon clouds during our experiment, which is a very big achievement, I feel, and a lot of science will come out from that. And one important aspect is the seed particle signature tracking, which we are now communicating a couple of papers regarding this. This is done with the SP2 extended range instrument, as well as with the mini AMS instrument. We have demonstrated that these are possible. We can indeed track the seed particle within the cloud, which is a requirement for physical evaluation, and that is possible currently. And also we do a lot of numerical modeling studies. And finally, I want to say that the randomization experiment that we did has resulted in nearly 276 cases in the convective clouds. This may be a unique data set to illustrate the hygroscopic seeding with the flares. And this may be I have indeed separated the clouds into less than 30 dBc and more than 30 dBc because they are indeed different. We need to think about actually at what stage or what type of cloud, what stage should we seed the cloud. Indeed, that is where we found that it is quite important. And we don't see any impact when the rain is already formed inside the cloud. Okay, so this is and we do see a significant impact when the clouds are seeded at an early stage of cloud. So, so there is a result like that, and these are some of the illustrations and the pictures to show you what exactly this is the ground site. Due to less time, I am not really going into details, and these are the aircraft instruments that we have used. Up to minus 22 degrees C, we have observations made, and with the three different inlets we have used. Actually, some of the people I want to recognize here, Kurt Hybert from WMI, Dr. Duncan Axisa here from he was with the DMT earlier. Actually, Duncan has been quite involved in our experiment, and they have contributed significantly to this phase of the experiment. And whatever I learned before from Rolof Brunjas, Rolof Berger, and a few others, I want to acknowledge that they all have contributed to our learning process, and of course, we will make further progress in this. And I also want to say that we also made a decision support system for looking at where exactly we should be seeding, and we have evaluated that particular, this is over our seeding area, and all those locations indicated with the black points are the observations, and the other ones are from model estimated locations. And these are, we also established a very big rain gauge network over the region, and these are our flight tracks. You can see that we have only flown within a 100 by 100 kilometer area, and this has been our experiment for over 2 years, nearly 8 months, 8 to 9 months of observations, and which gave us some really interesting results, which recently we have communicated, and it will be coming out if gets accepted. So this is again giving you a little idea about how is the liquid water content that we have observed in the clouds with the altitude, different research flights. You can see that a lot of liquid water content in the upper regions of the cloud. Just like over this region, there is a similarity, and we need to, maybe some collaborations can bring. Also, please look out for some of the published papers are available, where this is actually a seeding signature. We have tracked the seeding signature within the cloud. And convective clouds are quite complex. So the middle of the cloud, you can see an updraft, and the sides, there are downdrafts. There is something called subsiding motions around the convective clouds. When we think about these convective clouds, we have to pay attention to the dynamics. So I think a lot of further progress we need to make in terms of really quantifying the effects here. So we have also looked at radar observations, and due to limitation of time, I'm not going into details of it, but there are many challenges. This is my sketch illustrating finding the cloud, finding the conditions to evaluating the cloud. Actually, there are many steps that has to be followed, and we started our journey in 2013 for this particular experiment, and only 2018-19 we could accomplish that, and now the research will speak up. And today is India's 74th Republic Day. I'm very honored to be here, and I want to thank you all. I have a couple of announcements also regarding, one is regarding actually WMO expert team is compiling information on weather modification activities around the world. So please give us input to make the repository complete, information complete. And also, along with Ali, Ali and many others, Roloff and others here, I would like to invite you for IUGG special session on weather modification. Please submit a paper and please make it successful. And also there is a special issue in atmosphere that I hope everyone will submit paper and make it successful. Thank you so much. Appreciate your help.
Okay, great. Before we move on, I want to remind all the group leaders, please send Youssef or somebody from NCM your short one-page summary that we have. So we'll be collecting them and probably sending them around. But just make sure you do send them off and before you go. So that would be great. Are there any other issues or questions or general comments anybody wants to make? It's getting late. Okay, I'm going to hand off. Well, first I'd like to thank all the group leaders particularly and everybody in this whole room for making this session possible. I think this was really kind of exciting to probe and brainstorm and see where we are. I really enjoyed this session personally. And so thank you all.
Distinguished guests, it is my pleasure to announce that we have reached the end of our event. On the behalf of the National Center of Meteorology and the UAE Research Program for Rain Enhancement Science, I would like to thank all of you for your great and invaluable participation, attendance, and engagement in the 6th IREF. During the IREF, a one-of-a-kind global event, we have had the honor and opportunity to hear from some of the leading global and national experts, researchers, scientists, and stakeholders in the rain enhancement research. Please allow me to thank our speakers, panelists, and our participants for making this event possible. Your contributions have been vital in this. You made this forum a grand success. I hope you all have enjoyed the forum and have gained new connections and perspectives. And we are looking to see you all again in the next edition of the forum, the 7th IREF, collaborating and uniting to achieve water security together. I would like to take this opportunity to invite all researchers, scientists, and innovators to join UAE REF's quest to support achieving water security through the new cycle of the program's award, the 5th cycle. I would also like to quote His Highness, Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the United Arab Emirates and ruler of Dubai. The future belongs to those who can imagine it, design it, and execute it. It isn't something you await, but rather create. Before we conclude our event, I would like to ask all of you to join us here on the stage to take a group photo. Again, thank you very much, and until next time.